Today, we're going to look at one-way ANOVA, which is also known as the one-factor ANOVA, one-way analysis of variance or between subjects ANOVA. So one-way ANOVA is normally used to compare means of two or more independent groups so that we can determine whether there is a statistical evidence that the associated population means are significantly different. So one-way ANOVA is a parametric test, and by this, the assumption of normality has to be obeyed. The test applies dependent variable and the independent variable, which is also known as the grouping variable or factor. Some of the common uses for this particular analysis is that you can use one-way ANOVA in a number of areas, for example, in field studies, experiments, and quasi-experiments. So in that line, some of the tests you run may include statistical evidence or differences among the means of two or more groups, statistical differences among the means of two or more interventions, and statistical differences among the means of two or more change scores. So it is worth noting that both the one-way ANOVA and the independent sample retest, this can compare the means for two groups. So meaning if you do a one-way ANOVA to an independent sample retest and a one-way ANOVA for the sample that has got two groups, then we'll be in a position to get same results. So, but for one way, you will normally focus on means across three or more groups. So if you have three groups and above, you will preferably use one-way ANOVA and not the independent sample t-test. So what are some of the assumptions or data requirements for this particular analysis to be done? So one is your data must meet some of the requirements. The dependent variable must be continuous. And by continuous, we mean they must be interval or ratio level. Then the independent variable that is categorical. So here categorical data, I mean nominal or ordinal. Then independent samples or independent observation, meaning there's no relationship of those groups whatsoever. Then random sample, the data has to be randomly selected for this particular analysis. So there are no assumption of normality has to be there for each group of the dependent variable. And then the homogeneity of variance. So yeah, variance approximately equal across groups. And for this data, this we mean by the homogeneity. If you want to conduct this analysis, you simply click on Analyze, then Compare Means, then One-way ANOVA. So you can take this as a factor. See, it is the independent, and this can come into dependent list. So the contract section, you can always leave it on the postdoc. Here, if you have how to give good results, you can normally use the Bonferroni or the Tukey, and sometimes you can use the Chevron for this particular analysis. So that is if equal variances are assumed. But in the event that equal variance is not assumed, meaning the homogeneity, you do conduct a Leve's test, which you are also going to look, can use a Dunnett's T3 or a Dunnett's C for that particular analysis. So if you go back to so homogeneity of variance, so when the assumption is violated and the sample size differs from among group, the p-value for the overall f-test is not trustworthy. And then this condition warrants use alternative statistics that do not assume equal variance among population, such as the Brown, Forsyth, or the Welk statistics. So Brown, Forsyth, or Welk statistics normally is used to correct the value when, or the p-value when the equal variances or the equal variance is not assumed. So in this case, we have the options here. You can either use the Brown, Forsyth, or you can use the Welk just to correct the p-value when the equal variance is not assumed for that particular analysis. So when the assumption is evaluated, regardless whether the group sample sizes are fairly equal, so as I indicated earlier, For this case, you can use the DANET C or the DANET T3. That is in this particular section. So here, when equal variance not assumed, you can use the DANET T3 or DANET C. So in this case, how can you know that the equal variances are not assumed? So when the p-value of the 11 statistics is not significant, meaning it is significant, meaning it's less than 0.05. When you have a significance value that is less than 0.05, meaning the 11 statistic is significant, and in that case, equal variances are not assumed, and you will then prefer to use DANET T3 or DANET C to get the result for an analysis that equal variances are not assumed. So the outliers, as we have also highlighted this in some of the analysis that we have done, especially in paired sample t-test, independent sample t-test, and sample t-test, and one sample t-test. So outliers simply means we don't have extreme values or values that are extreme, but you have 0 and the other value being up to 100. So when the normality or homogeneity of variance or assumption for one-way ANOVA not met, and you want to run the parametric critical values test instead. So those are some of the key things to note when you are doing that particular analysis. So it's also worth noting that each group should have at least 6 subjects, and the designs has to be balanced. So hypothesis, we normally have the null and alternative hypothesis for this particular analysis that you will conduct before you make any conclusion for that particular data. So that is how you can do such analysis of one way. These are some of the requirements before you do, or the assumptions before you do the one-way ANOVA analysis. In our next tutorial, we'll be looking at how you can run one-way ANOVA, interpret the one-way ANOVA, and report one-way ANOVA. So, find this interesting, kindly hit the subscription tab below to subscribe to this channel. Thank you.